All right, so let's go. Question 1. Okay, so looks like we have a Gaussian, and so it's probability theory, and what it says is that random variable x is normally distributed with mean 120. Let me make this bigger. With the mean 120, the following diagram shows the normal curve for x, okay. Let R be the shaded region under the curve between 135. The area of R is 0.4. Okay, thanks for the information. Write down probability that the variable takes values between 105 and 135. Okay, that's just exactly the same as we were just given, right? I mean, between 105 and 135, that's the integral from 105 to 135. That's exactly that shaded area. So let me move this exercise to the side. So now you, if you're on TikTok, you lost it. And so the answer for A, very simple. The probability is given by this R, which is 0.4. Okay, you didn't see this, now you should see it. Okay, let me put this there. Nice. Okay, next. Find probability that x is less than 135. Probability that x is less than 135. Okay, so now we have our curve. Well, let me replicate it just like this. We have our area, which is symmetrically around the mean, right? Because from 120 to 105 is 15, and from 120 to 135 is also 15, which means that R is exactly in the middle, which means that since the Gaussian is symmetric, this area and this area are equal, and the sum of these areas, like in the entire area under the Gaussian, equals 1, and when I subtract R, which is 0.4, I get 2 times x, where x is this area and this area. Both of them I denote now by x, which means that I can quickly solve that this white area on the left side, which is equal to the white area on the right side, equals 0.6 divided by 2, which is 0.3. So this white area here, which is no longer white, is 0.3. So together with this area, so if I'm calculating the probability of being less than 135, which means that all the area of this Gaussian until that point. By the way, I have to make a disclaimer. I said that I'm pretending that I'm at the exam and etc. But obviously, because I'm explaining everything I'm doing, is going to take more time. So let's prepare for that. I'm not guaranteeing that I can do this in 2 hours, mainly because I have to explain everything and also kind of deal with my video capturing software and stuff, which I will pause sometimes just not to make this video too boring. Okay, so in any case, that's going to be 0.3 plus 0.4, which is 0.7. Maybe I should have timed myself actually. Well, I'm not going to do that anymore. And we move to question C. And in C, we're asked find, okay, the conditional probability that x is greater than 105 given that x is less than 135. Okay, if I'm just brutally going to be writing in terms of like how do you write conditional probabilities, is that conditional probability of A given B is the same thing as the probability of A restricted to B divided by the probability of B. That's the definition of conditional probability. Okay, so what's A intersected B? So now in our case, A is that x is greater than 105. And B is that x is less than 135. Okay, so let me just draw again somewhere here. Very nice. I'm sorry, let's make it a bit better. Oh, okay, so we have this Gaussian, and we have our A is everything to the left from 105, and B, which is everything to the, I'm sorry, A is everything to, by the way, I noticed I made this mistake left, right. This is not the first time in a video. And when I say left, sometimes I mean right. I don't know why. Maybe it's because I'm seeing myself like a mirror, whatever. I don't know why. So A is everything to the right of 105, and B is everything to the left of 135. So their intersection is this area, which is exactly R. So this means that this denominator up here is 0.4 divided by the probability of B, which we also just got in part B of the exercise, which is 0.7. So I claim that this is 4/7, and as far as I can tell, as far as I know, in fact, this is a valid way of writing an answer in an IB paper, so I would not go and calculate it with a calculator. That would be a waste of time, so I move on to the next exercise.